Executive Vice President at the Industrial Minerals Association. I have here with me Chris Greising, who is the Vice President for Government Relations at IMA. And on the phone we have Dr. Howard Sandler with Sandler Occupational Medicine, who I will introduce in just a minute. Before we get started, let me go through a couple of items. Everybody attending the webinar, your lines will be muted, so if you have a question, and we hope you do have questions, you need to type those into your dialog box on your screen, and we'll read those off to Dr. Sandler as we get the opportunity, and more than likely at the end of his presentation. The other thing I wanted to mention was that within about 24 hours of this webinar, we will send to you a copy of these slides. And Howard, that is okay with you, correct?
Sure, no problem.
Yeah, I don't think we've actually asked you yet, but we'll send out a copy of these slides synced to the audio of Dr. Sandler, and so you'll have that and be able to watch it at your leisure. Then finally, we are going to have, what's that?
There's a slight charge of 7 cents per slide.
Payable to Howard Sandler. So the only other thing I wanted to mention was that we are having another webinar on April 3rd on silica related to engineering controls. So watch out for that and sign up for it when you get a chance. So with that, I'm going to go ahead and introduce Dr. Sandler, and we do appreciate you're helping us out here today, Dr. Sandler. And SOMA, Sandler Occupational Medicine Associates, is a associate member of IMA and a very participative associate member, and we appreciate that. So Dr. Sandler has a long and distinguished career in regulation, healthcare delivery systems, research, and problem solving in occupational environmental health. Dr. Sandler received his undergraduate degree in medical education from the University of Maryland. He founded Sandler Occupational Medicine Associates as a response to business, labor's, and government's need for quality service-oriented approaches to address scientific, programmatic, and regulatory issues across a broad range of problems in occupational and environmental health. Dr. Sandler was trained in occupational medicine while serving as a medical officer with NIOSH. He has consulted with EPA, OSHA, NIOSH, and the Consumer Product Safety Commission, and for state and local government agencies. He has developed criteria for regulation and consensus standards, performed risk assessments and epidemiological research, and designed, implemented, and managed numerous programs in occupational and environmental health. Dr. Sandler's experience and expertise encompasses medical case management programs for workers' comp, liability, and environmental litigation. He has been qualified as an expert on warnings, exposure, causation, alternative causes, and impairment on chemical exposure cases. He has provided testimony before the U.S. Congress, state legislative bodies, and regulatory agencies. Dr. Sandler lectures and teaches, publishes extensively, and has served as a contributor and editor to several textbooks and periodicals. So with that, Dr. Sandler, we'll turn it over to you, and thanks again for your help today.
Well, it's my pleasure, and it's good to have an audience, many of whom I know. Some of you I may not know, but I can't hear you, so I'll have to assume that I know everybody. First slide, please. Silica, as you know, is probably the most abundant mineral on Earth. It represents 12% of the Earth's crust. For our purposes, there's two basic types. One is a crystalline structure, and one is an amorphous structure. The only one that supposedly has a health effect is the crystalline. The most common form is quartz, but there's other, what they call polymorphs. One is cristobalite, the other is tritomite, and usually you get them when it's the quartz has been calcined or heated. You can also have what we call combined silicates, and asbestos, talc, kaolinite are examples of those. However, it does not appear that the same degree or type of health risk occurs in silicates as it does in crystalline silica. Two important things in terms of looking at health risk are the fact that the degree of crystallinity and the freshness of the, quote, fractured quartz appear to have some impact and will increase the potential for health risk, especially for silicosis. Next slide, please. This just to give you a quick idea of the difference between crystalline silica and amorphous silica. If you look to the right, you'll see that the amorphous silica really does not have as regular a pattern as does the nice ring pattern that you'll see on the crystalline side. Silica is basically a molecule of one silicon molecule with two oxygen on it, and it does have that ability to form very nice structures that are indeed crystalline. Next slide, please. There's, depending on the geography of the specific location, these are rough percentages of how much you would expect to see of free silica, 30% in granite, 40% slate, and sandstone, is basically pure crystalline. But it varies tremendously. I know we do a fair amount of silica testing, not just in the United States, but throughout the world, and there's a very large range of silica concentration in various geological formations, and it can vary in one single little place tremendously. So you can't assume that there is a specific exposure unless you truly know and have an understanding of the percentage of free silica in a given area. Next slide, please. As Dr. Irving Selikoff, one of the, I guess, people who gave us asbestos-related problems, or at least recognized them, silicosis is a social disease with medical aspects, and I think that if one takes a look back at the history, next slide, please, what you'll find is that we've known for a long time that silicosis is a problem. Miners would get lung disease, and if you look back to even ancient times, you'll see that, that going back to the Romans, you'll find it. Ramazidi, the father of occupational medicine, called mining unpleasant and dangerous, but he still considered it a suitable punishment for criminals. I don't think we would do that these days. In the 1800s, we finally were able to develop things that could measure lung problems like the spirometer and the development of X-rays. Next slide, please. In the early 1900s, we recognized the extent of the problem. If you look at some of these percentages, you'll see clearly that in some studies, Lanza, who was of asbestos fame as well, showed that 69% had pulmonary disease in a Joplin, Missouri mining district, and 61% had evidence of tuberculosis with that. The U.S. Public Health Service in the 1920s and 30s finally, similar to what they did with asbestos, put in a I don't know if you would call it a PEL, an OEL, a TLV, but those were really not terms used back then. but they said that you would expect to see almost universal occurrence of silicosis if you went above 40 million particles per cubic foot with 35% free silica content. If you compare that to asbestos, back then they were using the number 5 million per cubic foot. So it gives you kind of some sort of a comparison there about relative health risk. Next slide, please. By the time we hit the 1930s, we're starting to really understand silicosis. There's even an article in 1934 by Dibble that looked at silicosis and malignant disease. So similar to the potential for litigation that occurred from some of the early studies of lung cancer and asbestosis, there are some historical bases here, although certainly we haven't seen anywhere near the amount of litigation in silicosis and related diseases as we have in the asbestos world. Next slide, please. We started to have conferences. The UK prohibited the use of sand at abrasive blasting in 1949. We looked at, in the 50s, some of the different levels, and mining industry accounted for 23% of, 66% of the cases, with manufacturing, especially in foundries, having about 27%. The EEC finally prohibited the use in abrasive blasting in 1966. By the way, there's a great film, for those of you who are historical buffs, made by the first female secretary, and her name was Perkins, and that's why the building at the OSHA building, the labor building, is named the Perkins building. And that was an excellent film about the use of wet methods to control dust or achieve dust suppression. Next slide, please. By the 70s and then into 2000, the question really became one more of a carcinogenicity issue, with NIOSH, IARC, and NTP all at various times declaring silica to be a potential human carcinogen and finally a known human carcinogen. However, if one looks at a lot of the studies, you'll find that the percentage of risk, unlike asbestos or other carcinogens, the percentage of increased risk for silica usually depended upon two main issues. One was the presence or absence of silicosis, and as well it was a quote level of roughly 30 or 40%, which translates to a standard mortality ratio of about 1.3 or 1.4, depending on what units you use. Next slide, please. The worst outbreak, which I think caused a lot of the push in the 30s, was the Golly Bridge Tunnel in West Virginia, where they were basically drilling through pure crystalline silica, and the mortality there after 1 or 2 years was 20%, with a morbidity of, of people getting sick of 75%. And a lot of these people were from acute silicosis, which we'll talk about in a second. Next slide, please. For the most part, we don't worry too much about the airways themselves, although there are a number of studies, which I will talk about, and a number of concerns about chronic obstructive pulmonary disease. But silicosis, the main disease that we'll focus on today, is really basically a disease of the interstitium, meaning the the supporting architecture of these airways. And I don't know if anyone has ever done an autopsy or been around an autopsy where someone had silicosis, but basically you can take out a lung and it feels like you're taking out a lung of concrete. When you cut into it with a scalpel, it really is like trying to cut into a very hardened sand. There is some concern, however, about chronic obstructive pulmonary disease, so one needs to be at least concerned and aware of the fact that the airways may also be involved with exposure to silica. Next slide, please. As I think you heard from, I think you had Galson talk about the exposure parameters. The particle size is important. This gives you a basic rough idea of where we are. For the most part, we're talking about particles of 10 microns or less as being the ones of concern. Next slide, please. However, I think what you have to really be clear on, next slide, please, is the fact that much of the exposure that occurred in the World Trade Center due to the concrete, which contains a certain amount of silica, that was pulverized. You were talking about very ultrafine particles, not quite nano-sized particles, but extremely small, and particle size and shape and crystallinity are all factors that are of concern. So basically what silicosis is just a series of scars within the lung. And if you will, you take a look at the next picture, please, next slide. What you'll find are these nice swirling, what we call silicotic nodules. They're concentric or onion skin arrangements of collagen, which is basically scar material. And that is totally different than what you'll see in things such as bisonosis or asbestosis or hard metal workers disease or pneumoconiosis, borreliosis. This really is a pathognomonic way of diagnosing silica. However, you really don't need to do that from a diagnostic standpoint. Next slide, please. Diagnosis is really a combination of a good, solid history of silica exposure and a chest X-ray that's using the International Labor Organization. Many of you know the term Class B readers, where we have small, rounded opacities of greater than or equal to 1/0. Although there are various texts and articles which say you do not need to have a chest abnormality on X-ray if you have pulmonary function tests changes and you have a history of silica exposure. That's sufficient. Obviously, the gold standard is a lung tissue histology or biopsy. However, I can't remember the last time I've seen anybody really biopsy for silicosis directly. I'm sorry about that. That's my wife, and I'm not going to bad hold music. So if you'll just up and leave a message shortly. And that I knew it was her, please. The times that you might want to do biopsies is when you're not sure about what the diagnosis is, and we'll talk about that, in terms of whether you're talking about sarcoidosis or some other disease that may look somewhat like silicosis on X-ray, but in fact may not be. Next slide, please. Back several decades ago, there was a realization that there was a need for standardization of how you read X-rays. And this is a classic form. This is by Dr. Henry Anderson, who's a epidemiologist with the health department in the state of Wisconsin, and Henry. He was kind enough to just let me use his report, but they're all basically the same. What you're talking about is looking at an individual who's taken a course, usually NIOSH sponsored or sponsored by others, and once you take the course, you become what's called an A reader. It's only when you actually pass the test that you become a B reader. I know some attorneys who have done so much work in asbestos that they actually have taken the course and have become B readers, and some of them aren't too bad, but you have to read a lot of x-rays to do that. And similar to it to be any good, and similar to what we see on x-rays, the readings vary tremendously. We tend to get a more what we call liberal reading on the east and west coast, meaning they find more disease than the film readers in the Midwest or in the central part of the country. I don't know if that has to do with politics or what have you, but certainly there have been some issues there, and there have been some more recent issues with certain individuals, and the fact that they haven't read and found silicosis or co-workers' pneumoconiosis dust, and so one has to be quite careful of choosing people who are B readers in order to make sure that you have a consistent quality program, especially when you are trying to do epidemiological studies. Next slide, please. Should have a difficulties with identifying silicosis, but there are things such as sarcoid or cryptogenic fibrosing. And interesting for those of you who may have reflux disease, there's a fair number of studies that show that gastroesophageal reflux disease, or GERD as you will, some of you may take that purple pill Nexium, GERD has been associated with pulmonary interstitial findings. And although the vast majority of silicotic densities on chest x-ray are truly round, there are a fair number that are irregular and are more like what you expect to see in what we'll call idiopathic interstitial fibrosis, which makes up approximately 60% of all interstitial pulmonary disease, or asbestosis, or some of the others. So one has to certainly look at that. Next slide, please. And remember, it's important to create or to understand that silicosis can progress, and that even if you stop with exposure, in certain instances, we're still trying to figure out exactly when and where that occurs. You can end up with something called progressive massive fibrosis and a conglomerate nodulation. You'll see the pathology slide to the left, basically showing the areas of concrete, if you will, that are being deposited in the lung. Next slide, please. Now, when we do talk about chest x-rays, this is what we're calling normal chest film. Typically, there's some parameter that you have to follow when you do the chest films, and there are various groups that do a good job. Certain hospitals are excellent. There are some mobile medical van companies that we work with that are also very good. There were some that weren't so good, and that became part of the litigation in the Texas area, where many of the quote plaintiff bar got a little overzealous and were getting x-ray readings that indeed were quote were called abnormal, but were in fact were either leftover asbestos claims that people were going back for a second bite at the apple by calling it silica or silicosis, but that sort of put a kibosh on a lot of that silicosis or silicosis litigation. This is a particular film which is classified as 0/0. That's a normal film. Next slide. This is the left side is again a normal film. You see the heart in the middle. You see the ribs. You see that nice black opacity, which basically means that your lung is filled with air, and that comes through on an X-ray as black. You should see sharp demarcations like at the bases and at the corners. But then if you look over to the right, you'll see this is what we call a large opacity. Up in the upper right corner, you'll see it's about 3 centimeters or greater. Sometimes when we see something like that, we get very concerned that not only do we have a silicosis of a large opacity type, there are both small and large, and we can certainly talk about that on questions and answers if you'd like. But you don't want to miss an adenocarcinoma or other type of more serious problem. Next slide, please. The differentiation between asbestosis and silicosis is very interesting in that if you look at the small densities on asbestosis, they tend to be in the bottom part of the lung, and you don't see, and you see these little densities throughout there as being very irregular shaped. There's not a specific type of shape that is useful for delineation of the particular type of pneumoconiosis. But if you look on the right side, what you'll find is this is a very serious case of asbestosis because it's a 3/3, which is the maximum perfusion. Typically, you start at 0/0 and you go to 3/3, and in between you have 0/1 and 1/0. The reason that you have those two readings are that it's up to the Class B reader to determine if, in fact, the predominant type is of the size of a certain number of millimeters, and that would be the first number. The slash following the slash is the secondary type that you see more, the next most frequently seen. In this case, you also see the shape and the size, and QRS represents rounded ones, and if you look closely on that X-ray, you'll see these little round densities, especially in the mid and upper aspects of the lungs, and that's is a classical case of pretty advanced silicosis. Next slide, please. There's some basic types of silicosis. Classical silicosis, where you expect that you can get some in low to moderate exposures, but usually it takes 20 years or greater of exposure to occur. In a small percentage of cases, you can see it at 10 years or less, but that's probably more where we get a higher level of exposure. Next slide, please. Not a high frequency, but certainly a significant frequency of these will go into progressive massive fibrosis. At a certain level, typically greater than 1/0 or 1/1, you'll see some PFT impairment. Usually that is a drop in the forced vital capacity. There's basically two basic measures that are used for pneumoconiosis, and one is the forced expiratory volume in 1 second, and that really represents an obstructive disease or a disease that affects the airway, whereas if you look at the forced vital capacity, meaning how much the lung can take in, that is usually a more representative of what we call a restrictive lung disease. And silicosis, for the most part, is considered a restrictive lung disease. And the restriction means that by making these scars that you destroy the elasticity of the lung and the ability for it to expand. Accelerated silicosis is the second main type, and that usually occurs at high exposures for about 5 to 10 years, sometimes 2 to 10 years. Next slide, please. One of the things that I think bears comment at this time is the fact that there is a lot of controversy on whether X-ray progression occurs after exposure cessation. There's numbers of various studies that show, especially in large interstitial capacities, there is a fair amount of progression. Sometimes some studies have found no progression. Our experience in probably over 10,000 people with several hundred people with silicosis is that we have not seen progression, even quote unquote with continued exposure at levels typically less than 0.25 milligrams per cubic meter of air. But there are studies that will show that at 1 to 10 milligram years, that means 1 milligram or 10 times the old PEL, that 10 or to 100 times that, 20% will progress to a 1/0, and 5% will progress to a 2/0 after the stopping of the cessation of the exposure. And that is, again, a lot of the progression may have to do with the amount of exposure and the length of exposure. There is not a yearly pulmonary function decline that's been associated with silica at low perfusion levels of 1/0 or 1/1. Next slide, please. The third type of silicosis is very dangerous. It occurs at very high exposures to fine particles like sand blasting silica flour. This is what we saw in the Gauley Bridge, West Virginia problem. The symptoms and the clinical presentation very similar to a proteinosis, or almost like a pneumonia. They tend to be rapidly fatal, and basically you suffocate. Next slide, please. There are other health effects that have been associated with crystalline silica. One is chronic obstructive pulmonary disease. Most of the studies come out of the South African gold mine, where there's a fair amount of silica there and a pretty high percentage. Histology, a NIOSH researcher, back in 2003, opined that you could see COPD without silicosis. This gives you some idea also of that at the quote NIOSH REL, which was 0.5, and it is, I'm sorry, 0.05, and the milligrams per cubic meter of air, and what is the new quote proposed OSHA PAL, that you would lose only about 6.5 milliliters over 4.5 years. Remember that the normal decline, the pulmonary system does age just like we all age, and our body functions do decline. But the normal decline is roughly 14 to 30 milliliters per year, and we have about 5 liters of total lung capacity. Next slide, please. One of the things that has been of major concern is the fact that there has been an association and a designation that respirable crystalline silica, quote, causes lung cancer. There are some studies that have related it to various other types of cancer, but I don't think that there's at this point, a cause and effect that's been established for any other organ sites. Probably one of the biggest questions that is still troubling researchers is the fact that, do you need to have actual silicosis to have lung cancer-related disease from silica exposure? There's thought and opinions on both sides of that. Some of the issue may be the fact that when you have chest films very similar to asbestos, a lot of people said you didn't need to have that you needed to have asbestosis to have lung cancer from asbestos disease. But when Cowie Kippen from Rutgers and working with Mount Sinai and Selikoff published in 1987, they published a study which said if you used a high-resolution CAT scan, that you in fact would be able to find lower levels of actual pneumoconiosis that don't pick up and might give you the illusion that there wasn't a presence of asbestosis or silicosis, when in fact there may well be. Next slide, please. Again, there's not a specific lung cancer that is associated with silica. Adenocarcinoma, this is just an example of one. You should know that unlike asbestos, there are no pleural effects, meaning the lining of the lung, similar to pleural plaques or pleural thickening that we see. And certainly there's no correlation between mesothelioma and exposure to silica. Next slide. The studies are really mixed in the lung cancer area. There's been various studies like Sand Workers by Hughes in 2001, which found an odds ratio of 2 to 5 times what the expected amounts were, and these were based on a lot of measurements. There was a greater risk for silicosis, but there was still some risk present for just silica exposure. But again, it's unclear whether, in fact, there was any fibrosis or not, simply because the chest X-ray is not that finite of a tool for detecting early levels of scarring. Next slide. Some other studies that were done showed smaller ratios of risk, but there's always issues of confounding variables, things that might cause lung cancer, such as smoking, radon, cadmium, polyaromatic hydrocarbons, asbestos, and others. And the Chinese populations usually studied have a very high level of smoking compared to other countries, and so many times the adjustment you make for smoking may or may not be sufficient. But the other issues that are of interest are surface size, particle age, if it's freshly fractured quartz, confounding, and even if peak exposures may have some impact on this. To date, most of the studies are looking at cumulative exposures, and they're certainly not looking at peak exposures. Next slide, please. In a more recent study from 2005 by Brown and Rustin, the standard mortality ratio for men was 99, which, for those of you who know a little bit about epidemiology, it's 100 or greater before you, 100 is, quote, what you expect, 99 is a little less, but you would really expect to see SMRs of 130, 140, and above, if indeed there were a problem there. In women, the SMR is a little bit higher, but the numbers were very small. We're only talking about 4 observed lung cancers versus 2.8, and that doesn't give you the type of power to really determine the predictability of what the risk truly is. In this particular study, there was no trend with cumulative exposure, meaning dose response, which you would typically expect. Next slide, please. In Cassidy, the study was a multi-center European case control study. There was a quote-unquote much higher finding for risk, all the way up to double the risk, or a little bit over double the risk, at the highest tertile, meaning they broke the exposure using exposure matrix into medium, low, and high. Leslie Stainer, who's been a long-term NIOSH researcher and now continues in other, I don't know where Leslie is right now, but there's an interesting editorial by Stainer which you might want to take a look at. When is enough evidence enough? Meaning, at what point do we really need to say that, quote, silica does cause lung cancer? Next study, please. Next slide, please. There's 2 other concerns about crystalline silica health exposure problems. One is certain types of autoimmune diseases, scleroderma, lupus, rheumatoid arthritis, and others. The study results to date have been mixed. OSHA does not, in its notice of proposed rulemaking, does not say that it's a foregone conclusion, but it certainly mentions it as a potential risk problem. Next slide, please. And the other main problem area is that of kidney disease. And there's a variety of different kidney diseases that have been studied. Again, some with mixed study results, ranging from end-stage renal disease to glomerulonephritis. These, again, are things that there are mixed study results over. Some people have found felt more comfortable calling renal effects associated with silica or silicosis. However, I think it's still an open question at this time. Next slide, please. Last but not least, let's not forget about tuberculosis again. There are certain infectious diseases, primarily tuberculosis, but other fungal infections that have been associated with silicosis and silica exposure. You can see with silicosis a much higher risk of the development of tuberculosis. And if you recall the historical slides that I showed you earlier, you'll note that tuberculosis indeed was a very common finding with individuals with silicosis. Next slide, please. This just gives you an idea of what the combination of silicosis with tuberculosis looks like. You'll see in the middle of that slide to the left that you're talking about some cavities or cavitation, and that's a very common finding with tuberculosis. In the X-ray to the right, you'll see that it's not that more smooth, well-perfused densities, but in fact you'll see bigger findings of opacities that are more consistent with tuberculosis. Next slide, please. Again, Hanizdo did study, and there are a number of studies on TB. Here are some of the basic findings of what they felt you would need to have before you would start to see an increased risk for tuberculosis. Next slide, please. You'll note that as the severity of silicosis increases, that the people without TB, or the percentage with TB, in fact increases. By the time you get to category 3, you're getting to the point where almost half the people after a 7-year follow-up will potentially have tuberculosis. Next slide, please. This is a study of, sorry the slide is not better than this, it's the best we could make it, from roughly late 60s through year 2000, which show that indeed that asbestosis deaths were pretty significant and growing in terms of because of the exposures that occurred in the 40s and 50s, whereas the exposure deaths from silicosis really dropped dramatically over that time frame due to probably a combination of respiratory protection, other types of dust suppression techniques, and recognition of the fact that silica does cause silicosis. So that's a nice story of showing a drop in the silicosis mortality. Next slide, please. This is probably not unexpected for most of you. If you look at all pneumoconiosis, meaning asbestosis, silica, coal workers' dust, etc., you would expect to see this type of mortality, meaning deaths over a certain time frame, and geographically that distribution is pretty consistent. If you look at the next slide, please, what you'll find is that for the silicosis mortality rates, by county, again, you see them in certain areas where silica is probably mined and utilized to a great extent. These are mortality slides and certainly don't represent all of the disease, because these would be probably a much larger and I think at that point next slide, please. We thank God a drop in the number of silica samples and percentage exceeding the permissible exposure limit. I know in the roughly 15,000 samples that SOMA has taken over the years, that we're finding that we're able to get, with certain types of controls, being able to get a high percentage down to what is the proposed action level of 0.025 milligrams per cubic meter of air, with only 1 or 2% going above that. And when you're focusing on what types of problems are causing the increased exposure, you can bring it down fairly well. Next slide, please. In 2002, NIOSH came out with a health risk assessment. It was not very well refined. It said that over the OSHA PEL, that 1 to 95% of workers would potentially get silicosis over a 40 to 45-year working lifetime. That's sort of a large range. It was a little bit smaller, and yet you're still talking about 1% at the NIOSH REL, which is now the proposed action limit of 0.025, and somewhere in between for approximately the current REL and the proposed PEL. At that time, the current prevalence was not really that well known, and they were getting about 300 deaths per year. Next slide. I'd like to conclude with some information on the medical surveillance and some of the newer studies on the notification of proposed rulemaking that was put out in 2013 by Silica. By OSHA. First, the additional new studies. First, next slide, please. VACEK in 2011 looked at Vermont granite workers. They used the job exposure matrix, and they found an odds ratio for silicosis of 13% increased risk for each 1 milligram year. Again, that's a fair amount of exposure. However, they did not see an odds ratio increase for lung cancer. Next slide, please. MUNDT in 2011 looked at the German porcelain industry, and it was a pretty large study looking at over 17,000 employees. They had roughly 8,000 actual air monitoring measurements, and they also used a job exposure matrix, which was designed by industrial hygienists. There they found no clear silicosis risk, consistent clear silicosis risk, until you got greater than 40 milligrams per cubic meter, which is roughly about the current PEL. They again found no evidence of lung cancer risk. However, as noted by the American Chemical Council and the ACC and the Silica Task Force, that comments were put forth and have been provided by Daryl and Chris, etc., to us. There's a lot of controversy of how NIOSH, how OSHA used the various studies and whether they cherry-picked them or whether they did a more exhaustive and equal-handed treatment of all of the studies. Next slide, please. Again, another porcelain study which showed that the threshold estimate for silicosis there was 0.25 milligrams, or 2.5 times the current PEL. Next slide, please. And I think the last study we'll be looking at is from Liu at 2013. They looked at 34,000 silica workers, and they found some increased risk at milligram years, especially at greater than from 1.12 to a little less than 2.9. But if you look at the quartile risk estimates, the lower one which would really be the one that we'd be concerned about with an OSHA PEL of 50 micrograms per cubic meter of air, it was not statistically significant. Interestingly, in this Liu study, they did find that the risk of silica and smoking was, quote, more than additive and possibly multiplicative. That's probably one of the first studies that I've seen where you really see that, synergistic effect. The lifetime risk at 0.1 milligram, the current PEL over 45 work years, was 0.5%, which is extremely low. They, however, found that silicosis was not necessary for increased lung cancer risk. Again, we're not sure. I don't believe they used HRCTs for all of the readings for the presence of silicosis. Next slide, please. Some of the, just to give you some basic statistics, from fracking alone, there's roughly 25,000 employees at 444 companies. They feel that half the PEL, current PEL, going down to 50, would be a reduction to prevent 688 fatalities and 1,500 cases of silicosis. At 50, the number of people requiring MMS, which is medical monitoring and surveillance, would be about 15,000 in general industry and about 336,000 in construction. If one looks at the average loss of life over the time period of exposures from 1996 to 2005, they calculate that they're saving about 10 years per individual. Next slide, please. Ken Rosenman, a noted epidemiologist, noted that the underreporting of mortality and morbidity, mortality meaning death and of course morbidity meaning disease, was anywhere from 2.5 to 5 times the current rate, so that there is a feeling that we're undercounting both the level of fatal silicosis as well as non-fatal silicosis. Next slide, please. Okay. The proposed medical monitoring and surveillance from OSHA is for exposure greater than 30 days a year at the proposed PEL of 50 micrograms per cubic meter of air. It's not, unlike many other OSHA standards where medical monitoring and surveillance kicks in at the action level, here it does not. The exams must occur within 30 days of employment, certainly no cost to the employees. The periodicity is every 3 years versus NISA recommended biennial exposure, with the exception of chest films, which stays at 4 years until you end up going to age 35 years or greater with 8 years of exposure. If one looks at the American College of Occupational Environmental Medicine evidence-based statement, they have a different periodicity of based on whether it's greater than or less than the proposed PEL of every 2 years or every 3 years. So there's not a specific consistency among the periodicity. Clearly, under the OSHA respirator protection standard, there is no specific periodicity for how many years, but I think it makes sense to you do perform respirator fit testing along with any of the medical monitoring and surveillance that you are performing. Next slide, please. The components of the exam are generally a very comprehensive medical history with special emphasis on the respiratory system, but also looking, besides smoking and asthma and chronic obstructive pulmonary disease, at renal and autoimmune disease, a detailed occupational history, an ILO class chest B film, which is the traditional way, or they say call it an equivalent, which is typically your HR or high-resolution CAT scan. However, the CAT scans are not cheap, and I don't think they're at the level at this point where most people would want to go to that determination and utilize those as an initial screening tool. But certainly for those people who come up positive or potentially positive, I know we in our programs use HRCTs as further evaluative tools. The pulmonary function testing is limited to FEV1 and FVC, as I mentioned earlier, and then you calculate the ratio to determine if you have an obstructive or restrictive pattern. Usually, if the FEV1 is down, it's more of an obstructive pattern that you would typically expect to see with cigarette smokers. The FVC, if that's down, you would expect to see that with people who range from obese to people who have interstitial fibrosis and those with pneumoconiosis. Next slide, please. Another component is TB testing, where they want people to take baseline tuberculin skin tests, which roughly are about $10. The problem with that is you have to come back within X number of 2 to 3 days and have that read again, which means you have to get your people to be willing to come back. There is something else called quantiferon test, which is a one-time blood test. I've seen the prices for various labs range from 150 to 200 a pop, but it is a one-time test. Some government agencies have been offering it for as low as $50 or even possibly less. There is consideration for looking at certain tests for both kidney or renal and autoimmune tests. The NISA protocol does call for looking at renal-based studies. One could perform these at relatively minor expenses, but again, it depends on how strongly you feel that there is a correlation between silica or silicosis and the development of kidney disease. From an autoimmune standpoint, there are a variety of different tests. One could use a rheumatoid factor or an anti-nuclear antibody, but these are not cheap, and again, it depends on how close you want to follow those. Another option is to look at your health benefit data and to determine the number of cases you have of renal disease and autoimmune disease by looking at ICD-10, or International Classification of Diseases, 10th edition, which will be in effect this fall, I believe, and see if you have an increased risk, especially in those workers who have a fair amount of silicosis in comparison to those, silica exposure in comparison to those people without. Next slide, please. Typical findings are that you can get a variety of symptoms, typical shortness of breath, cough, wheeze, crackles, and rubs. We used to use the terms rhonchi and rales, but those are fairly outdated terms, so there's going to be some inconsistencies in the way that symptoms are recorded in, and we have to be very careful when we put in medical monitoring surveillance so that we have consistent symptomatology listing, and so it's not all over the place and becomes difficult to perform comparisons. Again, we look for silicosis in terms of rounded but occasionally irregular densities. In silicosis, the densities, again, are mostly in the mid and upper lung fields. The densities and opacities, we look for perfusion, and that means how many there are, how prevalent they are, as well as by shape, size, and extent. We look for large opacities, and on pulmonary function tests, we look for significant pulmonary function declines. Typically, OSHA has been saying around 15% annually. If you see that type of drop, then that's somebody who really needs to be looked at more carefully. I typically don't wait till I see 15%. I would look at more of a 10%, but those are things that are individualized by company and by group, and there will be differences among various clinicians as to when they feel it is appropriate to follow up these people with significant changes. Next slide, please. You also going to have to decide who gets these examinations. Typically, it's people with either proven or anticipated exposures above the PEL. One can certainly use the action limit, which is required, for doing exposure testing. You have to make a decision between whether you want to use flow or volume spirometry. I would urge you to get a hold of the ACOM 2001 and the American Thoracic Society Task Force of 2005 in terms of a discussion of spirometry. Typically, the volume spirometers are give you much more accuracy. The chest film is, has specific delineations in terms of size. Next slide, please. And the fact that it has to be somewhat slightly underpenetrated to really bring out these densities, because if the film is overexposed, you will not pick them up. It'll tend to be, the film will be too black. Most individuals that we have worked with and most hospitals are going to digitalized chest films. There is established NIOSH guidelines for their use. Most practitioners and most mobile vans are already using digital films. I think the studies show that there is a pretty good correlation between Class B reads on digitalized films versus the hard copy. Certainly they're a lot easier to store, and they don't lose they don't become aged and lose their ability to be useful. The proposed OSHA standard requires hard copies until the ILO changes requirements. We're in the middle of that, and I would hope that OSHA would come to its senses and potentially say, look, it's really becoming the standard at this point in time, and to expect everybody to go back and get films or try to then take existing films or existing digitalized films and make a comparison is truly problematic. Next slide, please. There's information that needs to be provided by the employer to the professionalized healthcare professional, generally physicians, although if the scope of practice for a PA, meaning a physician's assistant or nurse practitioner, would allow them to do that in a certain state, certainly they could do it. The type of information, including what is the former, current, and anticipated duties of the employee, historical exposure levels for employees, the personal protective equipment or especially respiratory history, and any prior employment examination so that one can establish a ability to do a trend analysis. Next slide, please. Each healthcare professional must provide a written medical opinion of whether there's silica-related findings, and sometimes that means that you have to do second and third Class B reads, or do second films, or do more invasive or different types of investigations. You want to know if there's exposure or respiratory limitations. We have, as I said, in most of our companies have been able to continue to have people be exposed, albeit at very low levels, without respiratory protection, and we have not had to put people in respirators. Now, there's a lot of controversy about that, but it's been our finding with, again, thousands of workers that we have not seen a need to do that unless you really have a significant exposure. But if you're able to control your exposures, there's probably not going to be a need. Certainly, you have to document these findings to the employer and avoid any non-silica-related health findings going to the employer. Each employer must provide the healthcare provider's findings within 2 weeks of receiving them. Next slide, please. Some of the concerns are medical record keeping and chest film retention, as I stated, because of the digitalization. Typically, OSHA standards require keeping the exams, films for at least 30 years, plus the tenure of exposure. There's questions of whether, in fact, these films should be kept forever. There is no OSHA-mandated medical removal like there is in other standards, that if you have a 1/0 or something that you would, or 2/ that you know the person can no longer be exposed. There is no, quote, yearly exam if, quote, a radiographic evidence of 1/0 or greater occurs. However, our practice typically has been to put these people into a small group, since there's typically very few of them, and follow them annually just to be a little bit more cautious. Next slide, please. There is, within the both NISA and the NIOSH Notice of Proposed Rule, OSHA, excuse me, Notice of Proposed Rulemaking, annual TB testing if the exposure on the CXR, chest X-ray, is 1/0 or greater, or there's been greater than 25 years of exposure, then an annual TB testing is potentially required. Any positive findings should be referred to a board-certified pulmonologist. And the key on all this is what we call trend analysis. That means looking at silicosis progression on an individual as well as for the group, taking the medical findings and comparing them with your exposure data to see if indeed you are getting increased risk at from a dose response level, depending on what how much exposure is occurring at different places or different operations within your facilities. And as I had mentioned earlier, you can use the health benefits data, especially in International Classification of Disease, 10th edition, for renal and autoimmune disease identification instead of performing certain medical monitoring and surveillance procedures. Next slide, please. Okay. Again, we want to make sure that we have respiratory fitness for duty evaluations where necessary. For sometimes some people do have to go into situations where there will be greater than the PEL or potentially the action level. And I think the last point I'd like to make before I open up for questions and answers is the fact that some employees will deny or not want to take exams. My suggestion is that you make it a condition of employment, and because of both I think the ethical and moral requirements, as well as the standard that is likely to be finalized at some point, that you make it a condition of employment, and that you have to have a very good reason not to have it. Otherwise, I think you may have problems keeping people in exposure areas. And with that, I'm going to open the floor for questions and answers. Next slide, please.
Okay, thank you, Dr. Sandler. It was very informative, and we appreciate it. We do have a few questions for you. The first one is, what is the medical reason for crystalline silica causing ill health effects as compared to amorphous silica? Why would the ordered molecule structure make a difference?
I'm not sure that at a histopathological basis I could explain it. There's various, if you read through especially the OSHA 2010 risk assessment that was put forth, the pathophysiology of proposed silicosis is that the crystalline structure creates an inflammation. The exact precise mechanism, whether it's reactive oxygen species or some other approach, is unclear at this time.
Okay, thank you. And another question is, do you think that there will be a day when a B reader will be able to assign an ILO reading to a high-resolution CAT scan?
That's an interesting question. Right now, there are studies ongoing where people are looking at trying to come up with HRCT classification standards. If there's certainly a need for it, and people are willing to want to spend money to do HRCTs, then in fact, undoubtedly there will be a fairly good response from the medical profession to undertake such classification studies.
Okay, and then the last question I have right now is just a point of clarification regarding what does ICD-8 and ICD-9, et cetera, stand for?
ICD is the International Classification of Diseases. That's basically a World Health Organization, if you will, approach, so that everybody uses standard classification for diseases, standard criteria, and that there's actual numerical designations for each disease. They get updated periodically. The 8, the 9, the 10 stands for the 8th edition, the 9th edition, and the 10th edition. The 9th edition has been out for quite some time, but the 10th edition is now coming out. As a matter of fact, one of my occupational physicians is at a ICD-10 seminar, and we'll be bringing back some additional information as to what changes will be anticipated, especially from an occupational and environmental medicine standpoint for the ICD-10.
Okay, and that's all of our questions. Again, Dr. Sandler, we appreciate it, and Dr. Sandler and his staff of occupational health physicians and certified industrial hygienists are always there, ready to help IMA members. They've worked with a lot of our member companies, and they do a great job. So you have their contact information, and with that, that's all we have. Thank you.
Well, thank you all very much. I really appreciate the opportunity, and I hope you got your money's worth.
Absolutely. All right.
Thanks.
Everybody have a nice day. Bye-bye.
Bye-bye.